This is a tutorial on exponent properties. The first exponent property we're going to talk about is what to do with negative exponents. If we had two numbers, a and a was not equal to 0, and n was an integer, and we saw that a to the negative n, that would be the same as writing 1 over a to the n. So if you ever see a term with a negative exponent, you could just rewrite that in the denominator. So if we had 2 to the negative 4, that would be the same as writing 1 over 2 to the 4th. Or if we had x to the negative 9, that's the same as writing 1 over x to the 9th. This works in reverse too. If you ever see a negative exponent in your denominator, that means you can move it up to the numerator. So if we had 1 over 3 to the negative 3, that's really just the same as 3 to the 3rd. Or 1 over y to the negative 2, that's the same as y squared. So let's practice this a little bit. Here we have x squared times y cubed times z to the negative 4. Well, that's the same as saying x squared times y cubed times 1 over z to the 4th. Because this is a negative exponent, which means we take this whole term and we put it in the denominator. So we can rewrite this as x squared y cubed all over z to the 4th. Try the next one. Here we have 7 times x to the negative 3 times y to the 5th times z to the negative 1. Well, the 7 doesn't have any power, and it's just a constant, and there's nothing we can combine it with, so it hangs out. So we have 7 times x to the negative 3 is the same as 1 over x to the 3rd. That's multiplied by y to the 5th. And then z to the negative 1 is the same as 1 over z to the 1. So rewrite this a little cleaner. We'll have 7 times y to the 5th all over x cubed times z. The next property of exponents we're going to talk about is what happens when we have two terms with exponents that get multiplied together, or the product of terms with exponents. Here we have 2 squared times 2 to the 5th. 2 squared is just 2 times 2. And then we're going to multiply that by 2 to the 5th, which is just 2 multiplied by itself 5 times. So what we end up with here is 2 times 2 times 2 7 times, or 2 to the 7th. Same thing happens if we use variables. X squared is x times x, and we're going to multiply that by x to the 5th, or x times x times x times x times x. What we end up with here is 7 x's. So this is equal to x to the 7th. So let's look what's going on here. If we have x to the a times x to the b, that's the same as saying x to the a plus b. So here we had 2 squared and 2 to the 5th. We kept our base, our 2, and we took our exponents 2 and 5, and we just added them together to get 7. Same thing over here. We had x squared and x to the 5th. We kept our x, which is our base, and we just added our exponents. The 2 and 5 equaled 7. So let's try this again. Here we have 2 times a to the 7th times a to the 4th. Well, the 2 doesn't have anything going on, so it just stays. So we get 2 times, our base stays the same, times a, and then 7 plus 4 is 11. So our answer would be 2 times a to the 11th. Here's a bit harder one. We have 18 times x to the 6th times y squared times z cubed times y to the 4th times x to the 4th times z to the 7th, and finally times y to the 6th. Well, again, the 18 doesn't have anything to do, so we just put it out front. And then we look at our x's first. I have an x to the 6th and an x to the 4th. So we keep our base, and then 6 plus 4 is 10. So we'll get x to the 10th. Now let's look at our y's. We got a y squared, a y to the 4th, and a y to the 6th. So this is the same as y to the 2 plus 4 plus 6, or times y to the 12th. Now lastly, we have our z's. Here's a z to the 3rd and a z to the 7th. So we're going to get a z, and then 3 plus 7 is 10, so z to the 10th. So our final expression, or a simplified expression, would be 18 x to the 10th, y to the 12th, z to the 10th. Well, what happens when we're not multiplying? What happens when we're dividing? What happens when we have the quotient of terms with exponents? Well, here we have 2 to the 9th over 2 to the 4th. Well, 2 to the 9th is just 2 multiplied by itself 9 times, so 2 times 2, and that's divided by 2 to the 4th. So 2 times 2 times 2 times 2 again. Well, this 2 will cancel with that 2, and this one will cancel with that one, and so on, until we're left with just 5 2's. So 2 to the 9th over 2 to the 4th is the same as saying 2 to the 5th. Same thing happens with x's. If I had x to the 10th, and I divided it by x to the 5th, and started canceling, we'd be left with 5 x's. So this is x to the 5th. So let's look at what's going on. If we have x to the a over x to the b, we keep our base and then we subtract our exponents. Before, when we multiplied, we were adding them. Now we just subtract them. So say I had a to the 15 over a to the 6. This would be equal to a to the 15 minus 6, or a to the 9th. If I had n to the 7 over n to the 3, that's equal to the n7 minus 3, or n to the 4th. There's another way you can think of this. Remember our properties of negative exponents. If I rewrote n to the 7th over n to the 3 as n to the 7th times n to the negative 3, then we could use our properties of multiplication and add our exponents. So 7 plus a negative 3 is still n to the 4th. Well, our next exponent property is powers to a power. Or what happens if we have something to a power and then that whole quantity is again put to a power. So here I have 2 to the 4th. And 2 to the 4th is just 2 times 2 times 2 times 2. So 4 of them. But I want to square this now, so I have to do this all over again. So it's multiplied by 2 times 2 times 2 times 2. Well, here I have 8 2's. So this would be 2 to the 8th. Let's try this with the variables. Here I have x to the 5th. So 5 x's multiplied together, but I cube it, so I have to do this all over again 2 more times. And what I'm left with here is 15 x's. So this would be x to the 15th. So let's look what's going on. If I have x to the a and then all of that to the b, that's the same as saying x to the a times b. So if I had 2 to the 4th squared, I really end up with 4 times 2, or 2 to the 8th. X to the 5th cubed is x to the 15th, because 5 times 3 is 15. This applies other ways too. If we have a term to a power, and we put it to another power, say we have x times y to the 4th, that's the same as saying x to the 4th times y to the 4th. You can almost kind of distribute this in. But it's important to notice that x times y is really x to the first power times y to the first power. So when I take that to the 4th, I have to multiply each of these. That's why this is x to the 4th and y to the 4th. So if I had x squared times y to the 4th, well then my x squared, the square gets multiplied by 4, so we get an 8, and then the y to the 1, that 1 gets multiplied by 4, so we have x to the 8 times y to the 4th. Same thing happens with division. If I have x over y to the 3rd, that's the same as x cubed over y cubed. And remember, this is x to the 1 over y to the 1 cubed. So the 3 goes to the x, and then the 3 goes to the y. You can also pay attention when we have a negative exponent. If I have x over y to the negative 2, that's the same as x to the negative 2 over y to the negative 2. But these are negative exponents, so when we simplify this, we swap them, and we get our y squared over x squared. So let's practice this. Here we have a to the 4th over b cubed all squared, and then multiplied by a over b to the negative 7th. Well, the first thing I'm going to do is I'm going to bring this 2 inside the parentheses. So a to the 4th squared is a to the 8th, because 4 times 2 is 8. And that's over b cubed and then squared, or b to the 6th. Now we're also going to multiply this by bringing the 7 inside, a to the negative 7th over b to the negative 7th. Now when I multiply two of the same terms, I have a to the 8th and a to the negative 7th, I can add the exponents. So this becomes a to the 1st. And then 6 plus a negative 7 becomes b to the negative 1st. Well, then I'm going to bring this b up to get rid of this negative exponent. And this simplifies down to a times b, or just ab. Let's try this again. Here I have 4 times x cubed times y to the 6th times z to the negative 1, and all of this is cubed. So what I'm going to do is I'm going to take this cube and I'm going to cube the 4, cube the x cubed, cube the y to the 6th, and cube the z to the negative 1. So 4 cubed is 64. X cubed and then cubed again is x to the 9th. Y to the 6th cubed is y to the 18th, because 6 times 3 is 18. And then z to the negative 1 cubed again would be z to the negative 3. Now the next thing I have to do is move this z to the denominator, so we get 64 x to the 9th, y to the 18th, times 1 over z cubed. So this becomes a 64 x to the 9th, y to the 18th, all over z cubed. Now the last exponent property we have to learn is what happens when we have a 0 power. Well, any number with a 0 exponent is equal to 1. So if we have x to the 0, it's equal to 1, as long as x doesn't equal 0. And the reason why any number or variable to the 0 power is equal to 1 is because imagine you had 3 over 3. Well, 3/3 is equal to 1. That's no big deal. And if we had x to the 4th times x to the minus 4th, we could take x and add our exponents, and we get x to the 0. Well, imagine if I used the properties of negative exponents and rewrote this and put this x to the negative 4th in the denominator. We would have x to the 4th over x to the 4th. Well, any number over itself in the denominator would be equal to 1. So while this means exactly the same thing as this, we can see that this one obviously equals 1. And this one obviously equals x to the 0, which is why x to the 0 equals 1. And that completes our tutorial on exponent properties.